So today we're going to be talking about equivalent fractions. If you need some background knowledge on equivalent fractions, take a look at my fractions video on my YouTube page, Mr. Rant's class, and you will get the background knowledge that you need to be able to understand the information in this equivalent fractions video. Here we have an anchor chart. It says equivalent means equal. So we are trying to find fractions that take up the same amount of space. Two fractions are equivalent if they have the same size or they're at the same point on a number line. And we're going to look at this in more detail. You can always check your work by cross multiplying. And so how you cross multiply fractions is you take the first fraction and you multiply the numerator by the denominator, and then you take the first fraction and you multiply the denominator by the numerator of the second fraction. And so if we do this one here, 1/2 is equal to 3/6. And so we have that because 1 times 6 is 6, 2 times 3 is 6, and because they're the same, we know that it is equivalent. You can also make equivalent fractions by multiplying the numerator or denominator by the same number. And so here we have 1/3 times 2/2, and it gives us 2/6, and we look at this here and we see that it is equivalent. Same here, we have 1/2 times 4/4, and it gives us 4/8. And if you look at the two circles here, you see that it's taking up the same amount of space. And so here's another look at our anchor chart. Now I'm going to show you some examples of some equivalent fractions by using some strip diagrams. Just to give you a recap, a strip diagram looks like this, and it has unit fractions in each of the sections. And then how you can tell the fraction is by counting the unit fractions. For example, we have this one here. There are 8 sections, so 8 is the denominator, and there are 1, 2, 3, 4, 5 shaded in, and so this is a representation of 5/8 of the strip diagram that is shaded. Our first example of equivalent fractions are what is equivalent to 1 whole. And so we have 1 whole, and then we have 2/2, so 2/2. Then we have 3/3, which is 3/3, and 5/5, which is 5/5. And so here we have these fractions. They take up the same amount of space on these strip diagrams. The next example we have is 1/4, 2/8, and 3/12. If you look, these are all the same size, and you see that they take up the same amount of space. So this one is broken up into 4s, but you only need one of these to be shaded. This is broken up into 12s, and so you need 3 of these to be shaded to equal the same amount shaded as 1/4. And then these are broken up into 8ths, and you need 2 of these to be to be shaded. And you see that each of these take up the same space. It has the same amount on this one strip, even though they are broken up into 8ths, 12ths, and 4ths. They're shaded the same amount of space. Here we have the equivalent fractions to 1/2. And so 1/2 is a common equivalent fraction. There are a lot of fractions that are equivalent to 1/2. We have 2/4, we have 6/12, we have 5/10, we have 4/8, and we have 3/6. And so if you look at them, like I said, these are the same exact strips, but they are broken up differently. And so if you see here, when you look at this strip, you only need to break it up into 2s, but half of it is shaded. Well, this 4, when you break these 4ths up, they're broken up into 4ths, but you need 2 of these to be shaded to make half. This is broken up in 12ths, but you need 6 of these to be broken up into halves. So what you notice here is that the larger that the denominator is, the smaller these pieces are. So normally when we think of larger numbers, we think of a bigger quantity, and that is correct. There's a bigger quantity of spaces. However, the space has gotten smaller because it is still the same size shape. The next example of equivalent fractions we have is 5/6 and 10/12. Same strip, but they are broken up differently, but they take up the same amount of space. The next example of equivalent fractions we have is 3/4 and 6/8. And here they are equivalent because they have the equal amount of shaded space on their strip. You see that they take up the same amount on each strip, so they are equal. 3/4 is equal to 6/8. Our next example is 4/5 and 8/10. They're equivalent fractions because they take up the same amount of space on their strip. You see that they are equal. It's an equal amount shaded on both of the strips. Our next example is 2/5 and 4/10. And so, because we are getting down to our last example, you can see based off of the shaded space why they are equivalent. This is our last example, and we have 1/3 and 2/6. Looking at the fractions, you see that 1/3 is broken up into 3s, and you need to shade in 1 to equal 2/6 of the following one, because this one is broken up into 6, and you see that 2 of these equal the same amount as 1/3. So now you and I are going to get the opportunity to do some examples. We're going to identify some equivalent fractions, and we're also going to do some multiplication and division to see how we can get an equivalent fraction. This here gives us a breakdown, and it also tells us, I mentioned before that you can multiply to get equivalent fractions, but you also can divide. And so this first gives us the definition. Equivalent fractions are fractions that name the same amount. Here are some different ways to show fractions equivalent to 3/4. So here we have the circles, and we have 3/4, and then we have 6/8, and we have 9/12. So if you look at these, all of these circles are the same size, but they are partitioned a little bit differently. And partition is just another word for broken up, and they are partitioned differently. This is broken up into 4s, this is partitioned into 8, and this is partitioned into 12s. And so the same amount of each circle is shaded, and so that is the reason why they are equivalent. Now here we have another fraction, and this is a rectangle. If you pay attention, each of these rectangles are the same shape, the same size, and that is very important. They must be the same size. You can't have a rectangle that is a little bit shorter and then try to say, oh, these are equivalent. No, because they have to take up the same amount. And so we look here, this one is broken up into 4s, this one is broken up into 8s, and this one is broken up into 12s, and still the same amount on each of these are shaded. Next we have a number line here, and you see that the same space on each number line is represented. So 3/4, 6/8, and 9/12. All of these have the same space marked on red on the number lines. Though the number line is broken up into more spaces, however, it's still the same space marked on the number line because they are equivalent. Okay, you can also multiply or divide the numerator and denominator by the same numbers to find equivalent fractions. And so this worksheet had 2 typos, but I went ahead and fixed it. We have 3/4 multiplied by 2 and 2, and it gives us 6/8. So you multiply the numerator by 2 and you multiply the denominator by 2 to get the equivalent fraction. Then here, same thing, we have 3/4 and we multiply both the numerator and the denominator by 3, and it gives us 9/12. So it is equivalent because both of them were multiplied by 3. And so the division portion to this is 6/8 divided by 2/2, and it gave us 3/4. 6 divided by 2 is 3, and 8 divided by 2 is 4. For this is the portion that we work together. And you have to write in the missing numerator for the top one and the bottom one. And then this one you have to multiply or divide to get the equivalent fraction. So for this one, all we have to do is count. We have 2/3. This is broken up into 3s, and 2 of them are shaded. And so now we need to count and see how many of these are shaded over the 6. So we have 1, 2, 3, 4. So 4/6 is equivalent to 2/3. You see that it is the same size rectangle and the same space is shaded, so they are equal. And you see so that 4 of the 6 are shaded and 2 of the 3 are shaded. These are equivalent because they're the equal amounts are shaded in. So here we have 5, 6, and then we need to see how many 12s we have. So if you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so 10/12 is equivalent to 5, 6. Now this one is where you have to multiply or divide. And so if I'm looking here, this number gets bigger, so I know that I need to multiply. I know that 3 times 5 is going to give me 15. Because I multiply, whatever I multiply the denominator, I have to multiply the numerator. And so I'm going to multiply 5 by 2, and it's going to give me 10. And I can check my work by doing the cross multiplying method here. So 2 times 15 is 30. 3 times 10 is 30. And this is how I know that this answer is correct. Now, let's look here. We have squares this time. They are broken up into 4s, and then this one is broken up into 8s. And so 3 of the 4 are shaded in. And let's see how many of the 8s are shaded in. 1, 2, 3, 4, 5, 6. So 6 of the 8 is shaded in. So that means that 6/8 is equivalent to 3/4. On the number line, all you have to do is look and see that this is 2/3. If you go straight down, you see that 6/9 is equivalent. For here, we have to multiply again because you see that the 8 is going up by times 2 to get 16. And so if I'm multiplying 8 times 2 to get 16, I have to multiply 3 times 2 to get the numerator of this other number. 3 times 2 is 6, and that lets me know that 3/8 is equivalent to 6/16. Here we have a number line as well, 2/5, and the same exact space on the tenths is 4/10. I want to check my work to make sure that I have it correct. I'm going to cross multiply. 2 times 10 gives me 20. 5 times 4 gives me 20. This lets me know that I have the correct equivalent fractions. Here we have circles again, and this one is broken up into 6, and this one is broken up into 12s. And so I see that one of my 6 were shaded and 2 of my 12s were shaded. If you look there, it's an equal amount that is shaded, even though the number is partitioned, the circle is partitioned into 12 and 6 here. The same amount of space is shaded in, so that makes them equivalent. Here, we see that we have 1/2, and then we need to figure out what the numerator of this number is. If I start here and I go over here, it's going up, so I know that I need to multiply, and I know that 2 times 6 is 12. Whatever I multiply in the denominator, I have to multiply the numerator by as well. So 1 times 6 gives me 6. So 1/2 is equivalent to 6 over 12. Now here, we're going to have to divide because I see that I have 8 over 12 here, and that this number is going to be a 3. So when it's over here and you need to figure out what you need to do, you know that you have to divide because it's going smaller. When you are dividing, you are making numbers smaller. You are dividing a bigger number up into smaller sections. So I know that 12 divided by 4 gives me 3. And so whatever I do at the denominator, I need to do with the numerator. So 8 divided by 4 is 2. I just want to double check my work. And so I am going to multiply 8 times 3, and that's going to give me 24. 12 times 2 is also going to give me 24. This here lets me know that these are equivalent fractions. Now I'm going to show you 2 more ways that you can identify equivalent fractions, or you can figure out what is an equivalent fraction to another fraction that you already have. Okay, so our first example is Gaston makes 2 number lines to find equivalent fractions. And so you see that he has a number line here. It's broken up into 3s. We have 1/3, 2/3, and then a whole number, which is also known as 3/3. And I'm just going to put it here just so we can see it. And then we have this one where it's broken up in 6. So we have 1 6, 2 6, 3 6, 4 6, 5 6, or one whole, or 6 over 6, however you want to look at it. And we need to figure out which fractions are equivalent. It says circle all the correct answers. And just as a testing tip, when something says all, that lets you know there's probably going to be more than one answer. And so I want to look at each answer choice. So we have 1 6. If I identify 1 6, if I go straight up, do I see 1/3? No, I do not, because 1/3 is over here. So A is not an answer choice. I'm going to cross it out because I don't want to be confused. Then here, 2 6 and 1/3. Now let me look. If I have 2 6 and I look directly up, I see that these numbers are on the same space. So these two are equivalent. So I'm going to circle B because that is correct. Then we have C. We have 2/3, looking at 2/3, and then it says it is equivalent to 3 6. Well, if I go straight down, it is not the same as 3 6. So this here lets me know that these are not equivalent because 3 6 is here and 2/3 are here. It is not on the same space of the number line. So C is not correct. Now let's look at 4 6 and 2/3. If I look at my 4 6 here and I go straight up, I see that it is 2/3. So these here are on the same space of the number line. And so these are equivalent. Lastly, we have 2/3, looking at 2/3, and 2 6. These two do not have the same space on the number lines, therefore they are not equivalent. So my answers are B and D. My second example is the shaded model 2/4 is right here. Shade the model below and show a fraction of equivalent of 2/4, then write the equivalent fraction. So there's 2 ways that we're going to do this. I'm going to show you the way where we have to multiply to get the answer, and then I'm going to show you how we can just shade it in and to see. And so we have 2/4, and then we need to see that it's equal to something. So the first thing that we can easily do is find the denominator, because all we have to do is count the number of spaces that this is partitioned in. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we're working with something. We know that we have 2/4, and we know that we have 8 in the denominator because that is the total amount of spaces in this rectangle. Well, to do this, I'm going to multiply because I have a smaller number here, and then I have a bigger number over here. I know that 4 times 2 gives me 8. And whatever I do with the denominator, I have to do with the numerator. So 2 times 2 gives me 4. So 4/8 is equivalent to 2/4. So I can go ahead and fill this part in, but I also have another part where I have to shade in to show me. So what I'm going to do is I'm going to shade in 1, 2, 3, 4. Now if I look here, it looks just like this. The same amount of space is shaded in this 2/4 as it is in 4/8. So this here lets me know that these are equivalent. And if you want to check your work, by all means, we have 2/4 equals 4/8, and you can cross multiply. 4 times 4 is 16, and 2 times 8 is 16. And so because they both are 16, we know that they are equivalent. Thank you so much for watching this video on equivalent fractions. Like I stated at the beginning of the video, if you need some basic knowledge on fractions, there is a fractions video on my YouTube channel, Mr. Rants Class. There's also a video on my Instagram, Mr. Rants Class. And so please check out the fraction video because it is a prerequisite to knowing about equivalent fractions. Thank you again for watching the video, and I hope that you learned something.